I'm about to send it to you.
Okay, go ahead.
The problems are very long, I noticed.
Yes, they are. Trust me. This is one of the hardest parts of differential calculus is what they're going over right now with you. Soon as you're done with this, it gets a lot easier. They got a lot of simple rules for figuring out first derivative. The hardest way to figure it out is by using the limit quotient definition. Sounds like that's what they're doing with you guys right now. Let me take a look here and see if that's what I think it is. Let's see. Find the equation for the tangent to the curve at the given point, then sketch the curve and tangent together. Okay. You know the power rule yet?
Not very well.
Well, let me teach it to you because I'm not sure how they want you to do these. It doesn't say. The power rule is extremely simple. Let's go over it. Even if they haven't taught it to you yet, it's worth teaching it to you. If y equals 3x to the 4th power, then dy dx, which incidentally is the same as f prime of x, same as delta y over delta x, same as y prime. All of those things mean the same. That's terminology, different terminology. There's advantages to some terminology over another. The beauty of this terminology is it says you're going to take the derivative relative to x. Same thing there, same thing there. This one just says first derivative of y. Doesn't tell you the variable that you're going to take the derivative of with respect to. So it's not quite as robust, but it's shorter to write. So let's first of all, so when you use the power rule, you start with the exponent, multiply it by the coefficient, subtract 1 from the exponent. Simple as that.
Okay.
Let me give you a few tests. Give me the derivative of that.
Negative x to the 5th.
No, start with the exponent. Multiply it by the coefficient, which is 1.
Times 1 is 5.
X to what?
To the 4th.
Yep. Always subtract 1 from the exponent when you're done. Let's try another one.
Okay.
Y prime.
So it'll be a negative 3x to the negative 2.
The negative 4.
Oh, negative 4, okay. So to subtract.
Subtract 1. Always subtract 1 from that thing. Okay.
Got it.
All right. So this particular problem that they're giving us here, hold on. There's a number of ways to do this. I'm going to do it the simplest, most straightforward way. First of all, figure out what y prime is. Now, the derivative of a constant is 0, always, no matter what the constant is. Here, one
Okay.
I didn't give you. If y was equal to 13x, y prime equals what?
12.
No.
X.
Take the exponent, multiply it by the coefficient,
13.
times x to the 0. Well, anything to the 0 is 1,
Is 1.
including a
So
variable.
just
So
13.
basically, it's 13. So any time that you're taking the derivative of a constant times x to the 1 power, it's the constant, is what the answer is. And the derivative of a constant is always 0. Because remember what derivative is. Derivative is slope, right? Well, if I have a constant, say y equal 10, what's the slope of that line? 0. That's why the derivative of a constant is always 0. Now, let's find the derivative of this whole function. Because we're going to come up with the equation of the line. Well, the most important thing for the equation of the line is the slope, right?
Mm-hmm.
That's derivative. That's what first derivative means, is the slope of the tangent line. In fact, if you wanted 4 words to describe differential calculus, you could say slope of the tangent line, that would do it. You could also say instantaneous rate of change. It's not an average rate of change. You don't need calculus for average rate of change. Average rate of change is an algebra problem. But instantaneous rate of change is a whole different story, because now the rise is 0 and the run is 0. So you end up with 0 over 0. How do you figure out the slope of that? Well, we're going to do it right now. So the derivative of 4 is 0. I can do these one term at a time. The derivative of this is minus 2x. Okay? So what's the slope at the point x equal minus 1? In other words, what is y prime of minus 1 equal to? Plug it in for x. Plug that minus 1 in for x. What do you get y prime equal?
2.
That's the slope of the line they're talking about. Well, now we have an algebra problem, right?
Yes.
We have a slope and we have a point. Well, general format for the equation of a line is y equal mx plus b. Well, we just got our slope. At that point, the slope of the tangent line is 2. And we still need to calculate b, but we know that the straight line goes through that point. So I can plug in that point for y and x and calculate b. So I get 3 equals 2 times minus 1 plus b. b equals 5. The equation of the line is y equal 2x plus 5. That's the answer to number 5.
Okay.
Now, I am curious as to how they wanted you to do it. Since this is an odd, go ahead and look up the answer and see if they give anything other than just y equal 2x plus 5. They may actually go through their methodology of how they wanted you to do it, and that would be helpful for me.
Okay, one moment. So page 126, number 5.
You probably are just going to say y equal 2x plus 5.
Y equals 2x plus 5, is it?
They give you anything other than that?
It just shows the graph showing an upside down parabola with a line going through the point.
Okay, in other words, that equation, here's what the rest of it is. Hold on a second. In other words, if I graph the equation 4 minus x squared, that is a parabola pointing down, vertically shifted up by 4, right?
Mm-hmm.
Just like that. The equation of that line is our 4 minus x squared. And what they want to know is that at the point, it goes through the point minus 1 comma 3, right there. Minus 1 comma 3. And if I draw the slope of that tangent line, it's going to look like that. And it's going to have a slope of 2 on it. It's going to go through the y-intercept of 5. So the equation of the tangent line is 2x plus 5.
Okay.
Now, there are lots of ways, well, not lots. There's 2 ways to find the first derivative. Let me ask you whether this is the way they've taught you. The definition of first derivative, and remember that means slope, is the limit of f of x plus h minus f of x all over h as h goes to 0. In other words, I can take any function and find its derivative function by doing this. Have they taught you that yet?
A little bit, but I found it quite confusing.
Let's go through a simple problem using this definition, because most all calculus students have to suffer through this definition before they teach them the power rule. Power rule was easy, right?
Yeah.
Piece of cake. Well, let's take a function. Let's take y equals just a simple x squared. Well, we know what the first derivative is, 2x, right?
Correct.
Let's see if we can figure out what it is using this definition. Okay. Well, first of all, I got to figure out what f of x plus h is. Let me rewrite that thing so that it says f of x, not y. My function is f of x equal x squared. So what is f of x plus h equal to? That's what you always have to figure out. Always the first step in doing problems this way is to figure out what f of x plus h is. And the formula you use is whatever is in the parentheses you plug in for x.
Okay.
X plus h quantity squared. What is that? That's x squared plus 2xh plus h squared. With me?
Yes, because you just do substitute.
Yeah. So what I just wrote is what is circled up there. So I'm just going to put parentheses around it, even though I don't need them, just for clarification. Minus f of x, well, f of x is x squared, right?
Mm-hmm.
Put the whole thing over h, and I'm going to take the limit of this whole thing as h goes to 0. Well, you can see what the problems are going to be. I got 0 in the denominator. But here's what happens every time. That x squared cancels with that x squared. Now I can factor out an h from the remaining 2 terms, and I get this. I get h times 2x plus h, right? In the numerator. Still got h in the denominator. Just like the reason they spent 2 weeks on limits is to show you that this is the way you can solve these problems that start out 0 over 0. Well, notice the h's cancel. And now, what's the limit of that thing as h goes to 0?
So it would be 2x.
Yeah, the h disappears, and we're left with the 2x. So I use the full limit quotient definition. That's what this is called, the limit quotient definition, to come up with the derivative of this, whereas I could have done it real easy by just going using the power rule and saying it's 2x. But it's nice to know the power rule so you can check your answers, but I suspect that, I don't know, I can't really tell by looking at this page. They don't say use the limit definition, the limit quotient definition here. It's kind of a question of if they haven't taught you the power rule, then you only have one way to do it, and that's using this definition.
Okay.
So I'm going to suggest that we don't really have enough time to do very many of them, but let's do some difficult ones that I'm going to make up, because this is not as hard as it looks. Okay? Got this. I had to use this new program because my eraser stopped working on the other. And it's not my drawing tablet. It's the software of the OneNote that is part of Windows 10 that wasn't allowing my eraser to work. So let's make a function. This is kind of a tough one. Okay. So our goal is to figure out f prime of x. Now remember, what f prime of x is just the slope at wherever x is. Okay. So, but I want to teach you this because I'm almost 100% convinced you're going to have to do this. If anybody's going to have to do it, you're going to have to do it. I mean, you give me harder stuff than anybody else does. So there's no way they're letting you out of doing it this way. With me?
Yes.
You agree?
Yes.
Okay. Start off figuring out what f of x plus h is.
So would it be x plus h quantity squared?
Hold on. Here's our function, not the original function we started with. Our function's 1 over x.
So it'd be 1 over x plus h.
Okay, so now this becomes a limit of 1 over x plus h minus f of x, which is 1 over x, all of it over h, and I'm going to take the limit as h goes to 0. Now, what this becomes, the reason these are hard is because it's hard algebra. That's it. There's nothing hard about it. You can just do it the same exact way I've done both problems that I've showed you.
And I can cancel out the h's, right?
Not yet. First of all, you got to do the hard algebra, which is to subtract those two fractions. Well, how do I subtract those two fractions?
Common denominator. So multiply the other one by h.
I'm going to do it on the left. The common denominator is usually just the product of the two things. Don't multiply them together, just put it like that. And over here, I'm going to have the same common denominator. What goes here?
1.
No, so it's got to be the same as that. In other words, whatever I put there has to be the same fraction as what I started with. When you find the common denominator, you're not changing the fraction. Got to be x,
So,
right?
yes.
The reason I write it like this is so that you can so easily check to make sure that you got what you started with. Okay, what goes here?
H
X
times
plus
that.
h. Here's the way you figure out what you get in your numerator. Is you take this denominator, I don't know if you can tell where I'm pointing or not. Can you see where I'm pointing now?
No.
No, you can't. Okay, you take this denominator,
Mm-hmm.
divide it into your common denominator, and multiply by your existing numerator. Well, when I divide x plus h into my common denominator, I get x. X times 1 is x. So that's how I get the x here.
Okay.
On the other side, I divide x into my common denominator, and I get x plus h. And I multiply x plus h times the numerator of 1, and I end up with x plus h. Now I have the following. X minus h, because this negative sign has to be distributed to both the x and the h. In other words, that's in parentheses. You with me?
Yes.
All over x plus h times x all over h. I'm going to have to learn to write smaller. Okay?
Okay.
Now, let's simplify this. Well, the x's disappear, and in fact, that will always be the case, is that anything that does not have an h in it is going to disappear. By disappear, I mean cancel one another out. Okay?
All right.
So now I have to simplify this expression. Well, I'm dividing by h, so I'm actually dividing by h over 1. I can flip and multiply instead of dividing. So I'm going to flip and multiply it by that. You with me?
Mm-hmm.
Okay. Now, h's cancel, and look what I'm left with. Here I'm going to write it in red over here on the right. I've got minus 1 all over x plus h times x. Correct?
Yes.
What's the limit of that as h goes to 0?
-1 over x squared.
That's the derivative of 1 over x. Now let's go back and do it the easy way. Instead of writing 1 over x, I'm going to write x to the minus 1. Same thing, right?
Mm-hmm.
Apply the power rule. Start with the exponent. Minus x, subtract 1, minus 2. That's the same answer as this. Again, the limit quotient definition took us 5 minutes. The power rule took us 5 seconds.
Okay.
Okay? And if I had my druthers, every calculus class in the world would start with the power rule, not the limit quotient definition. But
Okay.
I'm not king of the world, so we can't do it like that. You got to do it the way they're going to teach it to you. And they may be a little smarter than some of the school systems out here in Colorado and not insist upon starting you off with the limit quotient definition. If it was up to me, I'd start you off with the power rule, and then there's a product rule, a quotient rule, a chain rule. Once you learn all 4 of those, then go back and do the more difficult stuff, the limit quotient definition. And it's entirely possible that your school, being a private school, is going to do it that way. But the only person that can answer that is you. I don't know. It's not going to do you any damage to do it this way. And if they have not taught you the power rule, you really don't have any other way to do it. You have to use
Okay.
this. You have to use this definition if you don't know about the power rule. So that's the only way I know how to tell you that you have to do this a certain way is what they've taught you and what they haven't taught you.
Okay.
We did two fairly difficult ones. We did two functions. One of them was x squared. The other one was 1 over x. And you can see the 1 over x was the much harder one to do because there's difficult algebra there. You're adding two fractions. You got to find a common denominator with variables. And then you got h's. You got to make sure you put the parentheses in. You got to do everything just right. You got to factor or flip and cancel the h's. In other words, there's a lot you have to do. But you'll notice that these techniques are very similar techniques as to how you found limits.
Okay.
In other words, this could easily have been a limit problem. And the solution would have been to find a common denominator and figure out what that limit is as h goes to 0. That's very similar to the problems we've been doing for the last 3 weeks. It's just difficult algebra is all.
All right.
Now.
Yeah, it's pretty difficult.
What's that?
I said it's definitely a tedious process.
Definitely is. And it's maybe worth knowing. I don't know. I have my doubts. Kind of, if somebody was going to explain calculus to somebody for the very, very first time, you would kind of do it this way because the whole thing of calculus is to find the slope of the tangent line. Well, how do you find the slope of a tangent line at that point right there? I can estimate it, but I don't really know what the slope of that line is. And figuring out the equation of that line is even tougher. But the first thing you can do before you figure out the equation of a line is to figure out its slope. And then once you have the slope and the point that it goes through, and they're giving you the point, so all you have to do is figure out the slope, then you can use the technique that I showed you to come up with the equation of the line. Start with y equal mx plus b. And that is the slope that you would get of that tangent line. And then you have to solve for b by putting in the point that they tell you it goes through before you can come up with the entire equation of the tangent line. But the way you figure out the slope of that tangent line is by putting an x there, putting up here x plus h, with h being some distance. That makes this point up here be f of x plus h. That makes this point down here be f of x. How would you figure out the slope of that line? You would say f of x plus h minus f of x. That's the rise. And the run would be x plus h minus x, which comes down to h. So that's how you end up with f of x plus h minus f of x all over h. And the whole point is, this is h right there. Well, we want this point here to get closer to that point there. So we're going to let h go to 0. And then we will have a tangent line, and we'll be able to figure out the exact slope of that tangent line. So that's where this thing comes from, is this drawing. And you've undoubtedly seen this drawing. It's in every calculus book. Starts out with a secant line, and then that becomes more like that, more like that, more like that. Eventually you have a line that is tangent to the point on the curve. All right.
Okay. Well, thank you.
You're welcome. I will talk to you next time, Taylor.
Sounds good. Have a good night.
You too. Bye-bye.